To finish off this module, we're going to look at now how to find the distance between 2 points in a coordinate system, as well as how to find the midpoint between 2 points in a coordinate system. So let's look at doing the distance between 2 given points. In this graph you have down here, you have points A, B, and C, and I'm asking you to find the distance between them, just using the units in the coordinate system. So take a moment, answer these questions as the best of your ability, and we'll go through them to talk about them. For the first two, it should have been a little bit on the easier side, especially, so if you look at the first one, for instance, there's a vertical orientation between A and B. Therefore, it's pretty easy just to look at the two coordinates, and basically, if you know how to count, you could see that there's 5 spaces between A and B, and as a result, I would say that they're 5 units apart. In a very similar circumstance, for B and C, they're horizontal, and in that kind of circumstance, I can just easily count how many spaces are between them, and there's 10, and therefore they are 10 units apart. So it's pretty straightforward about how to do that for situations where they're horizontal and vertically oriented. But when I look at the distance between A and C, it becomes a little bit more complicated. Even though this line is passing through some boxes, it's not the distance, going from here to here, for instance to here, is not one full unit. It might be a little bit bigger. So this might be, and this one too might be a little bit bigger. So it gets kind of difficult to say that they're the same distance. I'll have some students that may count these off and say, well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes that it passes through. But if it's not horizontally or vertically oriented, you can't just use the number of boxes it passes through as you go from one point to the other. So, how do we take care of this situation where I have a diagonal involved? Well, if I look at this carefully, I can't count the boxes, but I can look at this as, if I look at the x-coordinate portion and the y-coordinate portions, because basically the x-coordinate portions are giving me a horizontal distance, the y-coordinate portions are giving me a vertical distance. I'm basically forming a right triangle here, where I have the hypotenuse being the distance I'm actually looking for, with these two sides, these two legs being 10 and 5 units. So as a result, if I just apply the Pythagorean theorem and say that d squared equals 10 squared plus 5 squared, which is 125, and then I square root both sides, either say that the distance is the square root of 125. If I simplify that, I can get 5 times the square root of 5, or approximately 11.18 units. So basically, if I apply the Pythagorean theorem, I can find that distance pretty easily. And that is where the distance formula comes into play. The distance formula is simply a derivative of the Pythagorean theorem, because if I have two coordinates, x1, y1, and x2, y2, which you see here and here, and I want to find the distance between them, then what I would typically do is kind of look at and see, okay, well, how much of a horizontal movement do I have and how much of a vertical movement I have? And so I can make this right triangle. And basically the horizontal movement would be the difference between the x2 and x1. Assuming that x2, the way I'm drawing it here, is on the right. Oftentimes you'll put an absolute value around it to make sure it is a distance. For the distance formula, it's not going to matter, because we eventually will apply the Pythagorean theorem where I'm going to square that. Same thing here with y2 minus y1. That's how I would find the distance between these two, without having to necessarily count, because you can see that they're not necessarily always going to be on nice grid marks, and I'm going to be able to say exactly where they are. So applying the Pythagorean theorem, the distance, or d squared, is going to equal x2 minus x1 squared plus y2 minus y1 squared. And when I square root both sides of this to solve for d, I would end up with this. And that's what the distance formula is. If I'm finding the distance between 2 points, I basically take the square root of the difference between the x-coordinates squared plus the difference between the y-coordinates squared. So with this in mind, try the following. So if I'm finding the distance between these 2 points, now I don't see that, I see they don't have common x coordinates or y coordinates, so counting is completely out of the question on this. So I'm going to need to use the distance formula. So I apply the distance formula by substituting the x's into, -4 minus 8 squared, and I substitute the y's into y2 minus y1 to get 7 minus 2 squared. And when I work this out, I get the square root of 169, and that eventually becomes 13. Try another one. So for this one here, the distance between the points, again, I don't see any x coordinates in common or any y coordinates in common. Therefore, it's not horizontal or vertical, and so I can't just count this out. So I am going to use the distance formula. So the difference of my x coordinates is -6 minus 3. The difference of my y coordinates is -4 minus 2. Make sure you're always subtracting x from x and y from y. Students will sometimes, mix up x's and y's, then that's a common mistake that students make. When I work this through, I get the square root of 117. And that's essentially an answer because 117 is not a perfect square. Oftentimes you will see textbooks and other materials simplify this. Since 117 can be considered 9 times 13, then the square root of 117 can be rewritten as the square root of 9 times the square root of 13, which would be 3 times the square root of 13. Of course, sometimes you might be asked to write it in decimal form, and that's going to be approximately 10.82, rounding it to 2 decimal places. So you have that information. Now let's look at midpoints. So I'm going to ask you what is the midpoint between A and B on the number lines I'm going to present to you. So for the first one, where A is at -3 and B is at 5, where is the midpoint? Well, I mean, there's different ways if you have the number line in front of you. One way of looking at it is I kind of start from both ends and move my way to the middle until I meet at a common point. And if I move 4 spaces to the left of A and 4 spaces to the right of B, I'm at the same place at 1. And therefore, the midpoint is at 1 for this first number line. How about the second number line now, where A is at -2 and B is at 7? This one's a little bit more problematic because, if you try to count moving inwards, you're not going to meet at a space on the number line. I mean, you should meet somewhere between 2 points, somewhere between 2 and 3 to be exact. So that gets to be a little bit more problematic, especially if you start getting more complicated things like decimal coordinates and things of that nature. So noticing in midpoint 1 that I could do -3 plus 5 over 2, and that gives me that 1. If I basically average the coordinates on the number line for the 2 points, I'm going to get the midpoint. So for this case here, if I take -2 and 7 and average them, I get 5/2, which is about 2.5, and that's where the midpoint's going to be. So basically, if I know where my coordinates are on the number line, if I just average those two things together, that's going to give me the midpoint between them. But what about doing this for points on a coordinate system? It's not a whole lot different. The only thing I have to be keeping in mind is that I do have 2 sets of coordinates. I have x coordinates and I have y coordinates. And essentially, finding the midpoint, I'm just going to take the average of my x coordinates and I'm going to take the average of my y coordinates. So with that in mind, try it on this first example. So for this one here, all I'm going to do, again, applying the midpoint formula, is take the average of my x coordinates and the average of my y coordinates. So -5 plus 6 over 2 and 3 plus -5 over 2. That gives me a 1/2 and a -2 over 2. The 1/2 I can keep as it is. -2 over 2 is -1, or I could rewrite the 1/2 as a 0.5. Depends on what they want as decimals or fractions, and sometimes it's going to be different depending on what a question may ask you to do. Let's give it one more shot. So for this, again, I'm just going to take the average of my x's and the average of my y's. So I'm going to take -7 plus 9 and divide that by 2, and I'm going to take -8 plus 6 and divide that by 2. And when I get the results of those, I get 2 over 2 and -2 over 2. and then I would end up with 1, -1 as my midpoint. So that's all there is about midpoints and distances and their formulas. If you have any further questions regarding that, please make sure to contact me. Have a good day, everybody.